Have you ever thought about what it would really take to build an AI that can think like a world-class researcher? I'm not just talking about looking up facts. I mean an AI that can connect dots, solve really tricky problems, and navigate the entire web to do it. Well, let's get into it, because a new approach called WebShaper might just be the key. So here's the fundamental question, right? And it's a really good one. It's not about cramming more and more data into a model. The real problem is much trickier. How do you write the perfect textbook for an AI to learn from when that textbook doesn't even exist yet?
And that right there is the biggest bottleneck we're facing in creating these super capable AI agents. It's the sheer scarcity of high-quality training data. You know, it's like we want to train a PhD student, but we can only give them elementary school homework to practice on.
And let's be super clear, the internet is drowning in information. That's not the issue. The problem is a lack of carefully crafted examples that actually teach an AI how to perform complex, multi-step reasoning. And trying to make these examples by hand, it's just painfully slow and ridiculously expensive, and it's been holding the whole field back.
So, what have people been trying to do? Well, the old method has a pretty serious flaw. I think the best way to picture it was with a cooking analogy. Imagine you just grab a bunch of random ingredients from a totally disorganized pantry and then try to figure out what amazing, complex meal you're going to cook. Yeah, it's probably not going to end well. And this slide really gets to the heart of the change. The old way, the information-driven way, was to just scrape a ton of stuff from the web and then try to work backwards to somehow invent a complex question out of that messy pile. But the new way, what WebShaper does, is called formalization-driven. It totally flips the script. It starts with a detailed blueprint for the question first, and only then does it go out and find the exact ingredients needed to build it. And the problems with that old messy pantry method are pretty serious. When you start with a jumble of information, the questions you create have shaky logic. They can even have flat-out wrong answers. You also waste a ton of time collecting redundant data, making the whole process super inefficient. It's just not a good way to build a robust curriculum.
This is exactly where WebShaper comes in. It's a blueprint-first revolution, and it's designed to solve all those problems we just talked about. Instead of starting with messy data, it starts with a clean, mathematically precise structure for a question. It's a really elegant solution.
So, the secret sauce here is this concept called formalization. Think about it like this. Before a construction crew can build a skyscraper, an architect has to create a detailed blueprint. WebShaper does the exact same thing, but for questions. It uses the language of math, specifically set theory, to design the question's logical structure before any data is even touched.
So, what are these blueprints made of? Well, it all comes down to a few simple but really powerful building blocks. The most basic unit is called a knowledge projection, or KP. That's just a fancy term for a set of things, like, say, all people who were born in the 90s. Then, you can combine these sets using logic you already know. Intersection is your and a reunion is your or.
Okay, let's make this feel real with a simple example. A question like this can be perfectly mapped out with those building blocks. We're looking for a player who is in the set of people born in the 90s, and also in the set of players for this team, and also in the set of players who played in either 2004 or 2005. See how you can stack these simple, logical pieces to build something much more complex? All right, so we have the blueprint, but how does WebShaper actually take that blueprint and turn it into one of these incredibly complex training questions? It's a pretty cool process, actually. It takes the tiny seed of a question and grows it into a massive research challenge.
The whole thing happens in three main stages. First, it starts with a simple seed question, maybe something pulled from Wikipedia. Then, and this is where the magic happens, an AI called the expander agent gets to work, systematically building out that simple question, layer by layer, to make it way more complex. Finally, that super complex question becomes the final exam, the learning path used to train the AI model.
Now, the really crucial part is how it expands the question. The technique is called layer-wise expansion. This isn't just about randomly stapling on more facts. That would just create weird shortcuts for the AI to cheat. No. The expander agent does something way smarter. It finds a single, simple fact inside the question, and it replaces that fact with a brand new, multi-step sub-question where the answer is that original fact. So, for example, instead of just saying Berlin, it might replace it with the capital of the country that hosted the 2006 World Cup. It's a brilliant way to make the reasoning chain deeper and harder, step by step, without breaking the logic.
Okay, this all sounds incredibly clever in theory,
But here's the billion-dollar question. Does it actually work? Does this whole blueprint-first, layer-by-layer approach actually create a smarter AI? Well, the numbers are in, and the answer is a big, resounding yes.
So let's look at the GAIA benchmark, which is a notoriously difficult test for AI assistants. The model that was trained on the WebShaper data, the WebShaper 72B, hits a score of 60.1. And that's not just a little better, it's a huge leap ahead of other top open-source models. It's clear proof that this new training method is onto something big.
And what's really impressive, what shows this isn't just a fluke, is that the WebShaper dataset itself is just better. It's so good that it improves the performance of completely different AI models. You take the QQ model or the Kuan model, train them on WebShaper data, and boom, they get a major performance boost. This proves just how high quality and versatile this new approach really is.
But wait, it gets even crazier. This might be the most jaw-dropping result of all. After the first round of training, the researchers let the model basically practice on these perfect questions using reinforcement learning. And the result? Its performance on that same tough benchmark shot up by an incredible 13.5 points. That's a massive leap, and it shows this data unlocks whole new levels of reasoning in the model.
The researchers themselves really hit the nail on the head. They said this new method shifts the focus from just reactively organizing information that's already out there to proactively specifying the task from the ground up. It's the difference between being an archivist who just organizes what exists and being an architect who designs what will be built.
And that leaves us with a pretty mind-bending final thought. We've just looked at a system that can design better questions to make AI smarter. So what's next? What happens when an AI could not only answer our most complex questions, but can start to systematically design its own perfect curriculum to learn, well, to learn absolutely anything?